There's a structure sitting in a field in rural Texas right now that looks like an oversized concrete pill. No camouflage, no earth piled on top, no 20-foot shaft descending into darkness. Just a curved gray shell with a yellow blast door parked above ground like somebody forgot to bury it. And here's what nobody in the bunker industry wants you to understand. That $4,000 pod, built from a repurposed culvert section and a salvaged pressure door, will outperform almost every prefab underground bunker selling right now for under $100,000. I know how that sounds. For 70 years, we've been told the same thing. If you want to survive, you go down. Deep, the deeper, the better. The Cold War sold us that idea in 1961 when President Kennedy went on national television and told American families to build fallout shelters in their basements. The Office of Civil Defense printed 22 million copies of a pamphlet called The Family Fallout Shelter, and every single design in it was buried. By 1965, over 200,000 private underground shelters had been constructed across the United States. The logic was simple. Dirt stops radiation. Dirt stops blast waves. Dirt hides you. And for a specific scenario, a near-miss nuclear detonation in the megaton range, that logic still holds. But here's what the civil defense planners knew and never put on the pamphlets. Underground shelters kill more people through failure than they ever saved through protection. The declassified FEMA review from 1979, the one labeled CPG-1-8, found that of the private shelters surveyed across 12 states, 68% had critical structural or ventilation failures within 10 years of construction, water intrusion, collapsed ventilation pipes, sealed shut hatches from soil settlement, mold colonies that made the air unbreathable, carbon monoxide buildup from improperly vented generators. The government quietly stopped recommending private underground shelters by the early 80s, and the reason wasn't political, it was engineering. Going underground is the hardest, most expensive, most failure-prone form of shelter construction a private citizen can attempt. And the industry that grew up around it, the one selling you $40,000 steel tubes and $90,000 luxury bunkers with leather seating, has no incentive to tell you that an above-ground concrete pod, properly designed, beats almost all of them. So let's talk about the pod. The specific one that's been quietly replicated across Texas, Oklahoma, Montana, and parts of Idaho over the last 6 years. It started with a man named Travis, a former combat engineer who spent 11 years in the Army Corps before going private. He'd watched too many luxury bunker installations fail during his consulting work. Cracked seams, failed sump pumps, buried entrances no one could dig out after a tornado dropped 6 feet of debris on top. In 2018, he started building something different on his own land outside Stephenville. He took a section of precast reinforced concrete culvert, the kind highway departments use for storm drainage under interstate overpasses, 12 feet in diameter, 8 inches of wall thickness, rated to hold back 200,000 pounds of saturated soil load. He capped both ends with reinforced concrete bulkheads, cut a door opening, welded in a surplus blast door he bought from a decommissioned missile silo auction for $900, and set the whole thing on a poured pad on his back 40. Total cost, with ventilation, interior framing, and a small solar array, came to just under $4,100. Now compare that to what the bunker industry sells. Rising S Company out of Texas, one of the largest manufacturers in North America, lists their entry-level underground bunker, the mini bunker, at $39,500 before installation. Installation typically runs an additional $20,000 to $40,000 depending on soil conditions, water table depth, and excavation access. Their mid-tier Aristocrat model runs $120,000. Atlas Survival Shelters, based in Sulphur Springs, charges $78,000 for their smallest corrugated steel pipe shelter and over $200,000 for their larger family units. And those prices are before you handle permitting, electrical hookup, septic, water, and the inevitable repairs that begin within the first 18 months. Here's what those companies don't put in their brochures. The single largest cause of bunker failure in North America is not blast, it's not radiation, it's not even raiders or grid collapse. It's groundwater. The United States Geological Survey maintains continuous data on water table levels across the country, and in over 60% of populated regions, the seasonal water table rises to within 10 feet of the surface at some point during the year. Every underground bunker installed in those zones is essentially a concrete or steel boat trying to stay dry while sitting in a slow-moving underwater current. Sump pumps fail, seals degrade, concrete cracks under hydrostatic pressure. A 2019 survey conducted by an independent prepper community with verified responses from over 400 bunker owners found that 31% reported significant water intrusion within the first 5 years, and another 19% reported intrusion severe enough to render the shelter unusable. That's half of all underground bunkers failing their core mission within 5 years. The above-ground pod doesn't have that problem. It sits on a pad. Water flows around it. Gravity works for you instead of against you. If something leaks, you can see it, reach it, and fix it with hand tools in an afternoon. Try doing that 12 feet underground with a flooded entry shaft. Then there's ventilation. This is the silent killer almost no one talks about until it's too late. Carbon dioxide buildup in a sealed shelter is governed by a simple equation. A single adult at rest produces roughly 1 liter of CO2 per minute. In an enclosed space with no air exchange, CO2 levels become dangerous above 1% concentration within hours and lethal above 7% within a day or two, depending on volume. Every survival shelter needs active ventilation, and underground shelters need it more urgently because they cannot rely on any passive air movement. The standard solution is a hand-cranked NBC filter system, the kind based on Swiss or Israeli military designs, costing between $1,500 and $4,000. Above-ground pods can use the exact same filter systems, but they have a backup that buried bunkers can never have. Cross-ventilation through accessible exterior vents that can be opened, cleaned, and inspected without excavation. When a buried bunker's intake pipe gets blocked by debris, by a fallen tree, by ice, by an animal, the occupants have no way to clear it without surfacing. In a real emergency, surfacing might not be an option for days. That's how people die in shelters. Not from the disaster outside, but from the slow accumulation of their own exhaled breath. If you've made it this far, you already understand more about the real engineering of survival shelters than 90% of the people who've spent $50,000 on a hole in the ground. And if you want the complete blueprint, every dimension, every material specification, every ventilation calculation, every blast door sourcing list, every mistake that has gotten people trapped or killed in their own shelters, every step from empty land to fully operational pod for under $5,000, it's all laid out in the manual. Link in the description below. Now, let's get into what an above-ground concrete pod actually protects against, because the bunker industry has spent decades convincing people they need protection against scenarios that statistically will never happen to them, while leaving them defenseless against the scenarios that almost certainly will. The probability of a megaton-range nuclear strike landing within the lethal radius of any given American home is, according to RAND Corporation modeling, from 2021, somewhere between 1 in 800,000 and 1 in 2 million per year, depending on geographic location. The probability of being affected by a tornado, hurricane, wildfire, civil unrest event, prolonged power grid failure, or home invasion in a grid-down scenario is orders of magnitude higher. We're talking 1 in 200 to 1 in 2,000 annually, depending on region. So the question isn't whether your shelter can survive a direct hit from a Russian SS-18. The question is whether it can keep your family alive through the disasters that actually occur. An 8-inch reinforced concrete pod, properly anchored to a 30-inch deep poured foundation, will withstand an EF4 tornado with winds up to 200 miles per hour. That's been tested at Texas Tech University's National Wind Institute, the same facility that certifies FEMA-rated storm shelters. The concrete culvert sections used in these pods exceed FEMA P 361 standards by a significant margin. They will stop small arms fire, including standard rifle rounds up to .30-06 caliber at a distance greater than 50 yards. They will resist fire from wildfire ember showers, the actual mechanism by which most homes burn in major wildfires, Because there is no exposed combustible material, they maintain interior temperature stability within a 15-degree range of exterior temperature through pure thermal mass, without any active heating or cooling, which means in a grid-down winter scenario, the pod stays survivable while wood frame homes around it drop to outside ambient. And critically, they can be inspected, maintained, and modified by the owner without specialized equipment. That last point is the one that separates real preparedness from theater. The bunker industry sells the dream of a single capital purchase that solves the problem forever. Reality doesn't work that way. Every shelter requires ongoing maintenance, inspection, and adaptation as circumstances change. An above-ground pod is a system you can actually live with and improve over years. A buried bunker is a sealed time capsule that ages out of usefulness whether you check on it or not. There's another factor almost nobody discusses publicly, and it's psychological. Confined underground spaces produce measurable stress responses in most adults within 72 hours of continuous occupancy. Studies conducted on submarine crews, mine rescue teams, and the participants in the Mars analog missions at the Hawaii Space Exploration Analog and Simulation Site have all documented the same pattern. Cortisol rises, sleep degrades, conflict between occupants escalates, and decision-making capacity declines. The single biggest predictor of psychological resilience in confined shelter conditions is access to natural light and visual contact with the outside environment, even through a small port or periscope. Underground bunkers, by their nature, cannot provide this. Above-ground pods can, through narrow ballistic glazed viewports that maintain protection while preserving the visual and circadian anchors that keep people sane. A family that can see their land, see the sky changing, see whether the threat outside has passed or escalated, is a family that can endure for weeks or months. A family sealed inside a steel tube 12 feet underground with no visual reference often cannot endure for 2 weeks without breaking down. The bunker industry knows this. They just don't sell it, because it would force them to admit that their entire product category is solving the wrong problem. There's one last thing worth understanding. The pods in Texas, the ones built quietly over the last 6 years, are not isolated experiments. There's a loose network of builders sharing plans, sourcing reclaimed culvert sections from Highway Department surplus auctions, buying decommissioned blast doors from Atlas F and Titangent 2 site auctions where Cold War silos have been sold off to private owners. The Department of Defense's Defense Logistics Agency runs auctions where former military hardware, including blast doors, filtration units, and pressure vessels regularly sell for pennies on the dollar of their replacement value. A complete NBC-rated blast door, 24 inches thick, originally manufactured for hardened command facilities, has sold at these auctions for as little as $1,200. The materials exist. The knowledge exists. The only thing standing between most people and a genuinely functional shelter is the belief, sold relentlessly by an industry with everything to gain, that survival requires going underground and spending a fortune. It doesn't. It requires understanding what you're actually defending against, choosing materials and a location that match those threats, and building something you can maintain, inspect, and improve with your own hands over the years. You'll own it. The $4,000 pod in that Texas field has already survived 2 named tornadoes, 1 wildfire that burned to within 40 yards of the property line, and a 12-day grid outage during a winter storm that killed over 200 people in homes within 100 miles of it. Its owner was inside, warm, fed, and watching the storm through a 4-inch ballistic port. Across the same region, at least 3 luxury underground bunkers, all of them costing north of $80,000, were rendered inaccessible during that same storm because their entry hatches were buried under drifted snow and frozen debris their owners couldn't clear. Think about that the next time someone tries to sell you the dream of going underground. The ground isn't your friend, gravity isn't your friend, the salesman isn't your friend. Engineering, reality, honest materials, and your own 2 hands are the only things that have ever kept anybody alive when it actually mattered. Build smart, build above. And build it yourself before you need it. Consider what happened in Valonia, Arkansas in April of 2014 when an EF4 tornado with winds exceeding 200 miles per hour leveled entire neighborhoods. The families who survived in above-ground safe rooms built to FEMA P361 standards walked out within minutes of the all-clear. 2 households who had sheltered in underground storm cellars spent between 40 minutes and 2 hours trapped beneath collapsed debris piles, waiting for neighbors with chainsaws and pry bars to dig them out. One elderly couple, the Hendersons, were found alive but hypothermic, the husband having suffered a broken hip when the cellar door frame buckled under a fallen oak. They had paid roughly $22,000 for that cellar in 2009. Their neighbor across the street, a retired welder named Kurt Bishop, had fabricated his own above-ground shelter from quarter-inch plate steel and a reinforced concrete pad for under $6,000. He opened his door, stepped over a flattened mailbox, and walked to check on the Hendersons before emergency services arrived. The pattern repeats everywhere you look. In Moore, Oklahoma, in May of 2013, the National Weather Service documented that every single death attributed to that EF5 tornado occurred either in vehicles or in structures without proper above-ground reinforcement. Not one person died in a properly engineered safe room, above or below ground, but the recovery times told the real story. Underground survivors averaged 93 minutes to extraction. Above-ground survivors averaged 4 minutes to self-evacuation. The industry won't tell you these numbers because they can't sell you fear and convenience at the same time. They need you afraid enough to spend, but confident enough not to question the product. So they show you photographs of clean concrete corridors lit by warm LED strips, smiling families eating freeze-dried lasagna at folding tables 30 feet below grade, and they leave out the flooded sump pumps, the mold blooms, the seized hatches, the carbon monoxide alarms screaming at 3 in the morning because a generator exhaust pipe finally corroded through. Reality doesn't photograph well. But it kills reliably, and it kills the unprepared first.